Good day, Mathletes! Welcome again for a new episode of Math Amazing Lecture. For this time, let's discuss about the differentiation rules for trigonometric and exponential functions. Okay, let's have the first trigonometric function, which is the sine function. So if we have y is equal to sine of x, the derivative of sine x is equal to cosine x. So that's on how to get the derivative of any sine function. So let's have example. So remember that your derivative of your sine of x is always equal to cosine x. Example number 1. Y is equal to sine of 4x. So derivative of your y is y prime. Remember that the derivative of your sine is your cosine of your function of the angle 4x. Always multiply to the derivative of the given angle, which is your 4x. What is the derivative of 4x? That's 4. Then we will just need to rewrite this. We have 4. Let's put your numerical coefficient before your cosine. So we have 4 cosine 4x. Now, you do not need to multiply 4 by 4x because that's incorrect. This is a one function, that's a trigonometric function, that's the angle 4x. So, hindi mo pwedeng i-multiply yung numerical coefficient mo doon. So, the derivative of your sine 4x is equal to 4 cosine 4x. Now, let's have the number 2 example. We have y is equal to sine of your 3x plus 1. So the derivative of this, y prime is equal to, we have cosine 3x plus 1 multiply the derivative of the angle 3x plus 1, which is 3. Then let's rewrite. We have 3 cosine of your 3x plus 1. So that's the derivative. For number 3, we have y is equal to x times sine of 2x. Here, we have two functions. We have x and we have sine 2x. And remember our rule, it follows the product rule, the uv functions. So this is u dv plus v du. Derivative or copy your u function times the derivative of the v function plus copy your v function, the second function, times the derivative of your u function or the first function. Now let's do it. Y prime is equal to, what's your u function? That's x times the derivative of the v function. What is the derivative of sine of 2x? That's cosine of your 2x. Multiply the derivative of this. Don't forget 2. Going back to the product rule, we have plus. Copy your sine 2x times the derivative of your x, which is 1. So 1. So here we have y prime is equal to, let's rewrite. We have 2 times x, that's 2x times the cosine of your 2x plus sine 2x. Okay? So that's the derivative. Now let's proceed to the second trigonometric function. We call this one as the cosine function. And by rule, the derivative of cosine of x is equal to the negative sine of x times the derivative of the angle. So, let's rewrite that one. The derivative of cosine x is equal to negative sine of x. Okay, first example, we have y is equal to cosine of 2x. The derivative of this is negative sine, copy your 2x, multiply to the derivative of the angle 2x, Then let's just rewrite. We have negative times 2 is negative 2 sine of your 2x. That's the final answer. Let's proceed to example number 2. We have y is equal to cosine of your x squared. So we have y prime is equal to, the derivative of cosine is negative sine of x squared times the derivative of this, we have 2x. So we have the final answer as negative 2x sine of your x squared. That's the final answer, the derivative. For number 3 example, we have y is equal to the cosine squared of x. So here, we will be applying our previous topic, which is the chain rule here. So let's do it. Bring your 2 down, copy your cosine. Of course, we need to subtract 1. So we have cosine of x times the derivative of this. So the derivative of your cosine is negative sine of x times the derivative of your x, which is 1. Y prime is equal to, we have negative 2 there. We have negative cosine of x times the sine of x. So this will be the final answer. So that's how we apply cosine function in finding its derivative. Now let's proceed to the third trigonometric function, which is the tangent function. So please, let's replace that tangent function y is equal to cos x into y is equal to tangent of x. Now the derivative of your tangent x is equal to the secant squared of x. Okay, let's rewrite. The derivative of your tangent of x is equal to the secant squared of x. Now let's have the first example. We have find the derivative of your tangent of 2x. So it's very clear from the rule that the derivative of your tangent is just the secant squared of your 2x. And don't forget to multiply the derivative of the angle, which is 2. So let's rewrite. Y prime is equal to 2 secant squared of 2x. So that's the final answer. For number 2 example, we have y is equal to the tangent of 4x minus 1. So finding its derivative, we know that the derivative of tangent is just the secant squared. Then let's rewrite the angle for x minus 1. Then multiply the derivative of this, which is 4. So 4 times, of course we have 1 here. Then we just need to reposition your 4 before the secant. So we have secant squared of 4x minus 1. That's the derivative. For number 3, we have y is equal to the tangent of sine x. Y is equal to tangent of your sine of x. We know that the derivative of your tangent is the secant squared, and we just need to copy this one, sine of your x, and always multiply to the derivative of this. The derivative of sine x is cosine of x, multiply to the derivative of x. So it so happened that we have x only, so its derivative is 1. So let's rewrite that one. We have the secant squared of your sine x cosine of x. So that's the final one. Now if you want to have this one into other form, if you know other trigonometric identities that can be, that this one can be transformed into simpler expression or equation, you may do that. Okay? Now let's proceed to the fourth trigonometric function, which is the cosecant function. Cosecant. Sige. So, the cosecant function, the derivative of your cosecant of x is equal to negative cosecant of x times the cotangent of x. So, the derivative of your cosecant of x is equal to negative cosecant of x times the cotangent of x. Now, let's have the first example. Y is equal to cosecant of your 5x. So, the derivative y prime is equal to the derivative of cosecant is negative cosecant of your 5x cotangent of your 5x times the derivative of your angle 5. Then, we need to simplify. 5 times that negative is negative 5 cosecant of your 5x times cotangent of your 5x. So that's how simple to get the derivative of your cosecant function. For number 2, we have your cosecant y is equal to cosecant of your 2x squared. Now, let's find the derivative. We have negative cosecant. Just copy your 2x squared multiplied to the cotangent of your 2x squared. Then, we need to multiply to the derivative of the angle 2x. So, we have 4x. Then, let's just simplify. We have negative 4x cosecant of your 2x squared times the cotangent of your 2x squared. So that's the derivative. For number 3 example, we have y is equal to cosecant of your 3x squared plus 1. So we have y prime is equal to negative cosecant of this 1, 3x squared plus 1, cotangent of 3x squared plus 1 times the derivative of your 3x squared is, yes, you got it, 6x. Then we just need to rewrite y prime is equal to 6x times that negative is negative 6x cosecant of your 3x squared plus 1 times the cotangent of your 3x squared plus 1. So that's it. Very simple, right? For example, or for the 5th function, we have the secant function. Okay, for the 5th trigonometric function, we have the secant function. And the rule says the derivative of your secant x is equal to secant x times tangent x. So, the derivative of your secant of x is equal to sec or secant of x tangent of x. So, sectan. So, let's have the first example. Y is equal to the secant of your 2x. So, according to the rule, y prime is equal to secant of your 2x times tangent of your 2x times the derivative of the angle, which is 2. Then let's just rewrite 2 secant of your 2x tangent of your 2x. So that's the derivative. For the 6th trigonometric function, we have the cotangent function. Y is equal to cotangent of x. So here, the derivative of your cotangent of x is equal to negative cosecant squared of x. So let's have the first example. Y is equal to 4x squared plus cotangent of x. So let's find the derivative. Y prime is equal to, what's the derivative of 4x squared? We have 8x plus the derivative of cotangent of x is cosecant squared of x. So that's the derivative. Now let's proceed to the derivative of e squared. or e raised to the x power. Sorry. So the derivative of y is equal to e raised to x. The derivative of e raised to x is equal to e raised to x. Now let's have the first example. The derivative, or find the derivative of e raised to 4 plus 7. So y prime is equal to, just copy, 4x plus 7 times the derivative of the exponent, we have 4. So just write y is equal to 4 times e raised to 4x plus 7. Example number 2, y is equal to e raised to 3x squared. So y prime is equal to, copy, 3x squared times the derivative of the exponent, we have 6x. Then just rewrite it as 6x e raised to 3x squared. So that's how we find the derivative of your e squared, or e to the x power. How about the derivative of a raised to x? Okay, let's do it. The derivative of a raised to x is equal to a raised to x times the ln of your a. Example number 1. Find the derivative of y is equal to 10 raised to the 5x power. Now, y prime here is equal to, your a is the constant 10 raised to 5x, just copy, then ln of your a, which is 10. So, that's it. Times, the derivative of 5x is 5. So y prime is equal to 5 ln of 10 times 10 raised to the 5x power. For number 2, for number 2, we have y is equal to 2 raised to 5x. So y prime is equal to, we have your 2 raised to 5x times the ln of 2 times the derivative of the exponent, which is 5. So y prime is equal to 5 ln of 2 times 2 raised to 5x. So ladies and gentlemen, those are the different differentiation rules for trigonometric and exponential. So that's all. Thank you for listening. Happy learning!